Alright guys, so today we have a pretty interesting one. So for this one, I actually did it on paper, and then I realized, like, after checking my answers, that there's an easier way. So first we have an arrow. So we have a person. He's holding like a little bow or whatever. And he shoots his arrow at 30 degrees above, above ground level. So above this horizontal plane. And then later, it hits a target. Let's just say that's the target. He gets a bullseye because he's good. And so it's like the target's the same height. So we already know. So from what we know from this, we know that this is 30 degrees, 27 degrees. I mean, no. Let me just undo that. 49. I was thinking about the last problem that I just did. And what it's asking for is how far away is the target, and what is the maximum height reached by the arrow. So first, what we should do is just get we need the delta y value, and since it's upwards, we're going to draw a vector arrow over here, draw that vector arrow over there. And it's a 30, 60, 90, so instead of using like instead of using the sine of 30, we can just use 1/2 the hypotenuse, so we're going to get the VIF. Remember, this right here is VIF for the y. No, VYF, sorry. VYF. V. Oh my goodness, what am I doing? VIY. VIY. That was embarrassing. VIY is equal to 49/2, which is really just 24.5 meters per second, because this is acceleration. Let me just add that up there. And so now what we can do for this is, because it's at its apex, like question 17, we know that this right here is actually the velocity is going to be, the VF here is going to be equal to 0, but there's still constant acceleration. Gravity is always acting upon the object. So we can just plug this into the formula. So VF squared is equal to VI squared plus 2A delta Y. Now we can get 0 is equal to 24.5 squared plus 2 times negative 9.8, and then delta Y. So we're going to move this here, divide out by negative 19.6. Let me just 19.6, and we're going to be left with delta Y is equal to 30.6 meters. And because this is delta, we're going to add a positive sign because it's in the upwards direction. It's asking what's this distance, and the arrow is traveled from this level all the way up to there, so it's a positive vector. It has a positive magnitude. Alright, so next it's asking for the horizontal displacement, which is delta x. And originally what I did was I solved for time and wasted a bunch of steps, but then I realized there's also the other equation that we were given in class, and that's just v0 squared over g times the sine of 2 and the angle, and we're gonna get delta x is equal to, let me just scratch my eye, 49 seconds squared over 9.8. And then also the gravity in here is going to be positive. Square times the sine of 60, because it's really just 2 times 30, which is going to give us 60. Sorry, the handwriting's kind of bad. So when we simplify this out, I'm just going to plug this in. And we're going to get delta x is equal to 212 meters. So that's a short one. This right here is an interesting way. It will save you a bunch of time, and that's all for the horizontal projectile motion.